Hey everyone, and welcome. Today we're going to tackle a topic that trips up, well, pretty much everyone at some point, percentages. You know that feeling, right? You're staring at a sales sign, trying to do the math in your head, and you just freeze. Well, this one's for you. And this quote right here, it absolutely nails it. See, the secret to getting these right isn't about being some kind of math genius. It's all about understanding what the question is actually asking. The confusion almost always comes from the words wrapped around the numbers, not the numbers themselves. So let's dive into this language barrier. First up, we're going to look at the most common traps people fall into, because they really show why these problems can feel so darn tricky. It's all in the phrasing. Okay, these traps probably look a little too familiar, right? Have you ever been tempted to just add the number 20 when a problem says 20%? That is a classic misstep. And it all comes from treating a percentage like it's just a simple, standalone number. But it's not even close. Just take a look at these two questions. On the surface, they look almost identical, right? The only difference is two tiny little words, but those words, of versus increase from, they completely change the entire meaning, and they lead to two wildly different answers. This is that language barrier in action. One is asking for a piece of the original number. The other is asking for the original number plus a piece. Big difference. So if we all agree the words are the tricky part, then how do we get fluent in this language of percent? What's the secret key that gets us from the confusing words to the right answer every single time? That's what we need to figure out. Well, the answer lies in a really fundamental shift in how we think about this stuff. And this next part, this is the real aha moment that's going to change how you look at percentages for good. Okay, here it is, the big secret. A percent is not a number like 5 or 50. It actually has no value all by itself. Its only job is to describe a relationship between two other numbers. Think of it more like a modifier or an adjective. Seriously, think about it. If I just walk up to you and say 20%, what's the first thing you're going to ask me? 20% of what, right? It feels incomplete. It needs a partner, a number to connect to. It's always a piece of a whole or a change from a base. It just can't exist on its own in a vacuum. All right, so now that we've had that big realization, how do we actually apply it? Let's build this idea into a super simple but really powerful framework you can use to nail these problems every single time. Here it is, a simple two-step plan. Step 1 is always translate the words into a clear mathematical plan. Before you touch a single number, you figure out what the problem is actually asking you to do. Are you adding something, subtracting, just finding a piece? You've got to get that roadmap first. Then, and only then, do you move on to step 2, which is to identify the part and the whole for the calculation. You see, the actual math is the last and honestly the easiest part. The secret is all in that first translation step. Okay, theory is great, but let's put this framework to the test. We're going to grab that tricky problem from the beginning and we're going to solve it step by step using our new translation tool. So here's our problem again. A quantity increases by 20% from 50. What is the new value? Now, let's resist that urge to just jump at the numbers. We're going to focus on the language first. Step 1 is to translate. That phrase, increase by 20% from 50, it doesn't just mean 50 plus 20. No way. It means we start with our original number, 50, and then we add an amount to it. And what is that amount? It's 20% of 50. This little expression right here, that is our translated roadmap. Okay, now for step 2. We just look at our roadmap. The only real calculation we need to do is that little piece in the parentheses. What is 20% of 50? In this case, 50 is our whole, and we need to find the part that represents 20% of it. And that calculation is pretty straightforward, right? 20% of 50 is 10. This is our part. This is the value of the increase. Now, this isn't our final answer, but it's the critical piece of the puzzle that we needed to find. So now, we just take this calculated part, this 10, and we plug it right back into our roadmap from step 1. The plan was always to take our original number, 50, and add the increase, which we now know for a fact is 10, and there you have it. 50 plus 10 is 60. By focusing on the language first, we created a clear plan that led us straight to the correct answer. No guesswork required. So, if you remember one thing, remember this. A percentage isn't magic. It's just a tool. It's a multiplier, a totally predictable way to describe a relationship.
Once you learn to translate the language, you're the one in control of the tool. It doesn't control you.
And this kind of gets you thinking, doesn't it? This idea of a language barrier, it's not just about percentages. So I'll leave you with this question to chew on. What other areas of math, or any complex topic for that matter, might suddenly get a whole lot simpler if we just stopped and focused on translating the language first? Thanks for tuning in.